Hello, good morning, everyone. Good morning, Dennis. Thanks for joining
Morning.
us today. And hello, kids. It's so good to have you guys here. If you are here, because we can't see you, but we want to know that we see you on the chat box. So say hi to us. And like I said, I am personally very excited this morning because we have Dennis, who has such an interesting story to come and share with us about his journey from making batteries. You know, the batteries that you put in your TV remote, that you put in your phone. He is very experienced at making batteries that are bigger and more powerful. And not just that, he makes the batteries to put inside motorbikes. So very exciting innovation that Dennis has done. So I'm personally very excited that he's come here to talk to you. More than that, we have been talking about climate change, right? We have been talking about how our Earth is getting warmer. So Dennis is going to talk about how it is that we want to make our transportation system less polluting to the world, and doing less in terms of putting carbon in the atmosphere. So these are all very important things, and I'm so glad that Dennis has done so much work in this area, and he's going to be sharing with you. So I hope you guys are ready. And Dennis, I will let you take it away.
Hi, hi. Thank you for the opportunity, and I hope that my sharing session will let you all understand more about electric vehicle and also what is the importance of the issues of climate crisis. So I will just bring you through what I've been doing so far. I have been in the industry for almost, can say that 25 years. But all this started with during my younger days where I started a lot of hands-on building bikes, doing all this during my school days. So, but today topic is all about electric vehicle and tackling the climate change. So I hope that in between I would able to see more question from you all, which is um, hopefully beneficial to you all. So when I involve into electric vehicle, um, in the world electric vehicle in the world for vehicle like our motorbikes or a combustion car running on the road is actually contributing carbon emissions is actually contributing about 40% to our atmosphere. So combustion vehicle, the carbon emissions is so severe and is still increasing day by day. When you talk about carbon emission, imagine the from the exhaust pipe, the carbon coming out from the exhaust pipe. We weren't able to see how bad the smoke is, but for instance, like when you put in a 1 liter of petrol, you are actually emitting 2.36 kilo of carbon emissions. So 2.36 kilo, physically, if you hold on it, it's very heavy. But in from your eye, you weren't able to see it because it's already floating in the atmosphere. So this is where now climate crisis we have to able to manage the carbon emission. So that is why one of the big contributes to reduce the carbon emission is by going to electric vehicle. When we talk about electric vehicle, where is the energy come from? It coming from the battery. So the battery is the one that able to power the vehicle and move the vehicle or run the vehicle. So and by tackling the climate change, you are seeing that year by year the vehicle of electric vehicle will grow tremendously. So especially this few year onwards, there are many countries already looking into changing from the combustion vehicle to electric. So uh, probably you can see that the industry started 10 to 12 years ago, whereby uh, uh, there is a battery, they call it hybrid. There's a battery and an engine, which is still combustion, but is already able to reduce the carbon emissions. But if you want to totally take away the engine, you have to have a full battery powered electric. So the transitionals will be from the hybrid to electric. And I believe that everybody have heard about a Tesla. Tesla have changed a lot of people mindset to change their vehicles to electric. Um, Tesla started, say, 10 years ago, and they have made the people see that people believe that not only combustion car were able to give you the speed or give you the range. Full electric power car for Tesla it is still able to give you the performance of a car. If you talk about speed, electric car can do much better than the combustion car for speed. If you talk about range, now Tesla car can go as far as like 600 kilometer per charge or 700 kilometer per charge. Even though the charging will take you maybe an hour or 2 hours, by using a normal home plug, maybe it charge you for 8 hours. That is how you manage it. But in terms of converting to electric car, you are still able to perform like a normal car. So now, if you look at the business for Tesla, one company, their market value, the company value is is still higher than the rest of the normal car manufacturer. So this means that the potential of the electric car is so great compared to the combustion going forward. So this is to tell you that the opportunity for electric car is going to it's going to be there. It's going to be a great opportunity for everybody if you get involved into electric car. I'm sure everybody have heard of those high-end car like Mercedes, BMW, um, and they did a great job by designing their cars. But within the 10 years, the electric car have taken over whatever that they have done so far. So bear in mind, if anyone have not seen Tesla, you can please check it out. But maybe I would just probably want to put up a question to you all, whereby have you ever heard of a Tesla electric car, and how you feel about a Tesla car? If anyone want to raise up your question, I will be able to answer. If not, I will continue to carry on. So this is to also let you're aware that to make an electric car, the components of making the electric car is so much lesser than you use a component to build a combustion car. And And the components that you use lesser, meaning that you don't have to manufacture, you don't have to have so many manufacturers to make the components. The moment that you reduce the components, the factory won't consume more power. The factory won't need so much natural resources to make the components or to make the parts. So the good thing is that by doing electric car, you are using lesser natural resources material. So this is before you put the car running on the road, you already reducing the carbon emission or the greenhouse gas. So this is one of the key components to to manage our climate issues. So bear in mind that even though we have less parts to make electric car, but the technology of it to be able to reduce more and more is still need to have more people, more company going into research and development to build a more efficient electric car. So today we can see that there are more and more companies, more and more people are already interested into putting their resources, putting their capital into building up a perfect electric cars for people to use on the road. So it comes to what I'm doing right now. I'm already doing it for almost 12 years right now. But I'm actually focusing into electric scooter, which is, we call it electric two-wheelers or electric scooter. And uh, the electric scooters or electric vehicle, the key of it is still about the battery. So based on my experience, I have been making or doing lithium battery since 20 years ago. So what is lithium battery? Lithium batteries, we call it as a rechargeable battery. Rechargeable battery is you charge it like your mobile phone. You charge it, you use it until the power drops, then you charge it back again. So, so when you have a rechargeable battery, you don't have to keep on changing a battery to power your scooter or to power your car. You need to have a rechargeable battery. So what is the best rechargeable battery right now to be able to power electric scooter or electric vehicle? At this moment, is still lithium batteries. And rechargeable battery, they have many type of technology. But if you just look at the whole overall, basically there is only 4 technologies of rechargeable battery. We call it as lead acid battery, nickel cadmium, nickel metal hydride, and lithium batteries. So with this evolvement of technology of lithium batteries, with these lithium batteries, then only we can do electric vehicle. If we start using lead acid for electric vehicle, it won't be able to bring us very far. The charging time will be very slow. The after a full charge, the range will be low. But if you use a lithium battery energy density is so much more compared to the other technology, where lithium battery is the most ideal battery right now to be used in electric vehicle or electric scooter or electric car. So for me, I'm actually very much focused into electric scooter. Until now, if anyone have any question, you can raise your question. If it not, I will just continue to carry on what I'm doing as of now. So this is to show you, to let you understand that the battery you have, like the batteries that you use in a remote control, you use in your toy car, or any of the toys that you are playing with. There is a double A battery or triple A battery. All this battery is non-rechargeable. We call it primary cell. If you're non-rechargeable, you throw it away, you're also polluting the environment. So on the primary cell or non-rechargeable cell, we are not able to use it for electric vehicle. So that's where the rechargeable batteries come into play for electric vehicle, whereby if you see that 1859, the rechargeable battery of lead acid started, and lead acid, even though it started in 1859, there is still widely used of lead acid battery. If you go to the normal car right now, even in the normal cars do still have a 12-volt of lead acid battery. So lead acid battery is still very widely used. And then followed by 1960, you have nickel cadmium. 1980, you have nickel metal hydride, and it follows until 1992, lithium battery started to be used in our mobile phones. So where is the most lithium battery being used is actually in our mobile phones and also our laptop. But today, the lithium battery is able to join it as much as possible to make it into a very big battery pack to power your electric vehicle. So this is the technology of rechargeable battery as of today. Whether in future lithium battery will still be one of the components for electric vehicle or not, it is still there is still a possibility of we call it as the coming one will be solid state. But I'm very sure that there will be other technologies that will come in and supersede the lithium technology. But as of today, lithium technology is the one that will able to power the big usage like an electric vehicle. So to let understand that a normal motorbikes, you have so many components to make it into a motorbike. You have gearings, you have a chain, you have sprocket, you have so-called the engine. Inside the engine, you have so many components, whereby in terms of electric motorbikes, you just have a motor, a controller, and a battery. So that is where the opportunity of growing the technology is so great compared to a combustion engine. Combustion engine, there are so many components there that you needed to make a motorbike to run. So this is how simple it is on the electric motorbike. We don't have, if you look at the tire, and then the motor is actually attached onto the tire. So when the motor spin, the tire will follow to spin. That's how we actually move the whole vehicle. If you look at the engine motorbike, you have engine in the center, you have a sprocket, you have a gearing, you have a chain. to pull the tire to move. But in terms of electric, the design that I'm doing, it's basically the motor is attached to the wheel. You don't have so many sprockets or chains to move the wheel. So these have reduced a lot of what I call inefficient components. So that's the design of the electric scooter that what I'm doing right now. And another picture you can see is that this is how the battery is being made. You have this just like that's how when you see a lot of the picture, a lot of all these AA battery, but lithium battery is almost the same. You have a multiple cylindrical battery, and you make it into one battery pack. So just to explain more about how I designed this lithium battery is basically by using so-called 560 pieces of the lithium batteries to make it into one battery pack. And the 560 pieces of the battery cell to make into one battery pack, you need to have a way of doing the connection. And the connection that I have designed, basically is we call it as a non-spot welded. So I would like to share more about how I designed this battery, unless you all have interested and you would not like to have any question about this. I don't see any question as of now, but if you after using it, okay, I have one question. If we throw a battery in dustbin after using it, if it gets water, somehow will it explode? Very good question. Battery is not supposed to just throw it in a dustbin. You're supposed to recycle it. Uh, as there are few types of batteries currently, like AA battery. Of course, when you throw in a dustbin, when it in contact with water, there is a smoke that coming out. So the answer is yes, but it still depends on a primary cell or a lithium cells. So the best is that you don't throw it into the dustbin. You need to be able to know how to recycle the battery. Unfortunately, I think not many places that you have a separate bins for battery. But if you can, you're trying to look for a bins where separate out from a general dustbin. That will helps. That will helps on the battery exposed to danger, because we wouldn't know that this is a lithium battery, or this is a nickel cadmium battery, or this is a nickel metal hydride battery. So I would suggest it's best that we find a dedicated bins to throw the battery, not simply throwing a battery to any of the dustbin. So why does an electric car cost so high? It's always talking about economic of scale, whereby, for instance, today, cars is like 1 year for the normal cars is like the whole world. They already have a quantity of 10 million units. So 10 million units versus maybe today electric car is only 1 million units. So definitely on the costing standpoint, electric car today is still unable to compete with the combustion car. That's why the cost is still high. And on another reason is that when you buy a combustion car, you buy an engine car, you doesn't include the petrol. For instance, you use petrol to run for 5 years. If that will be your total cost of buying an combustion car, and 5 years time, how much petrol that you put it in, that is your total cost for a combustion car. But for an electric, you have your batteries that replacing the fuel. The battery is already you have to pay in advance, and the charging is still a cost of charging, but charging is very minimal from cost from the electricity. So today, I can of course the car price is still higher by double, but I believe that 5 years or 8 years down the road, the price of electric car and combustion car will be the same. So this is where, when the volumes grow, the cost will come down. And the battery costs have come down tremendously compared to 10 years ago. For instance, I think everybody knows about power bank charging your mobile phones. Um, 10 years ago, power bank sells for maybe 150 ringgit. But today, power bank you can buy it for 20 ringgit. When the volumes grow, the battery price will be reduced. So today cost is high. It doesn't mean that throughout the years electric is always high. Electric within 5 to 8 years will definitely be a lot cheaper or will be the same as a combustion car. Thank you for the question. So it still boils down to the cost. You see the main parts of it, you have the motor, you have the battery, and you have the controller. The controller, we call it as like a computer. Um, the all these all these parts is already lesser than a combustion car. That is why when the volume increase, the price will definitely be able to drop tremendously. So that's is not something that in future you to handle or to tackle the climate change, you have to pay higher for electric vehicle. No, electric vehicle will definitely cost will definitely be able to come down, and the conscious of us handling the climate issues by using the electric car to reduce the carbon emissions to be able to manage the climate issues. So one of the good things for electric, either electric powertrain, electric powertrain is like an engine. Electric powertrain, when you have a motor, the motor is moving. The moment that you want to accelerate the motor or the vehicle downhill, you can actually turn it into like a dynamo. You actually reverse the polarity, and it become a generator. That generator can actually charge back to the battery. So the kinetic energy that you lost, you are able to recoup back to charge the battery. So it means that the energy loss you still can recoup back to charge the battery by using it again. So these are the technologies that we try to improve by uh, by recouping back the energy. Uh, uh, of course, the best is to recoup back 100%. But the energy loss that today you can recoup back is probably 30%. So there is a lot more efforts to be put in to be able to recoup back the energy from the lost energy. So this is one of the very important technologies that we need to improve by recouping it back. I want to explain more on a powertrain energy. For instance, a combustion car, when you put 1 liter of petrol into your car, and the engine will generate the power. So 1 liter of petrol, the engine that generate power, you only generate about 30%. That is the best technology right now for a car engine. So you only able to harness or to generate 30% of the energy to power your combustion car. But when you come to electric powertrain, when you come to the motor, the energy that you put in, for instance, 1 kilowatt of energy that you put in, you're actually able to get 98% of the energy out. So if you look at it like a combustion car, the efficiency is only 30%, but the electric motor is already achieving 90 and above. So this means that uh, you you don't loss. There's a lot of loss in the combustion, but in terms of electric vehicle, your efficiency is so good. So that is the reason where we really need to push electric vehicle in this coming future. So for us to design a electric scooter, you still need to find where to charge your electric scooter. So I'm designing an electric scooter, which is you need to be able to use the common AC plug to charge your scooter. So AC plug, you can actually get it easily. You can able to get a tripping plug to charge your scooter. So the design, when you want to go to the market, you still have to think of how convenient. When people want to buy your scooter, you need to make it as convenient as possible for the user to be able to charge. And to be able to charge, tripping plug is the most common plug that you can get anywhere. So that is the design of our electric scooter. But when we always there is always a question of people say that when there's always a question of when your car is out of petrol, you need to go and look for a petrol station to pump petrol. But for an electric motor or electric car, for you to look for a trimming plug, it's actually everywhere. So it's so much convenient to charge electric vehicle compared to putting a petrol inside your vehicle. So this is just for your knowledge. Any questions so far that you want to know about the charging or anything about the powertrain technology? I will still carry on. Okay, how is batteries related to climate change? Um, of course, battery, there is still a components where you are actually using natural resources to build a battery. And it's still not totally able to I mean it's still something that a component that you use a natural component where you will harm climate, but if you do a comparison of a combustion vehicle and electric, it able to reduce and manage the climate issues. We can't able to totally eliminate where to of course take care of the climate, but this is the best technologies available right now to be able to to manage the climate change. So the 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 question of batteries related, the batteries able to convert vehicles to become an electric car. That is how uh, when you use an electric car, there is no carbon emissions. It's already able to manage the climate change. Hopefully, I actually answer your question where that's where you are referring to. If not, you can actually ask me back again. Thank you. So, in terms of electric scooter that Eclimo, I just now I didn't the company that I actually founded, Eclimo is Eco Life Mobility. The key of I started this electric scooter is that people would think that if it's electric, whether the scooter have to be slow or whether it can be better or better than the combustion motorbike. When I started this in 2008, I wanted to have a scooter that's able to run 100 kilometers per hour, and the battery can last you for 5 years or 8 years. So this is the basic target that I want to achieve for an electric scooter. So it means that you need to have a very efficient motor. You need to have a battery that can last you for 5 to 8 years. And you need to have a battery that can run 100 kilometers per hour. You need to have a battery that can able to take the vibration. So this is the technologies that we call it non-spot welders. I managed to achieve that in year 2012, where you're able to run at a speed of 100 kilometers per hour, and yet by a normal using a normal tripping plug, you can able to ride for 90 to 100 kilometer range by using a normal plug to charge. And you have to make it so simple. If you look at the picture, you make it so simple that the center is the battery, the wheel is the motor, and you have a controller to control the battery and the motor. So you have to make it, you have to make the whole scooter simple in order for me to be able to manufacture it without using much natural resources. So this is the key to for the battery to power the scooter. And we still talk about after 5 to 8 years, you still need to throw away the battery. But one of the key target that I'm trying to achieve is that even though 5 to 8 years, the scooter doesn't run for 100 kilometer or 90 kilometer range. After 5 to 8 years, the scooter will probably run only like 50 kilometer or 60 kilometer. But for a user of scooter, they would say that it's not enough for them to use for a day. So they want to change into a new battery. So when you change to a new battery, what happened to the old battery? The old battery still have maybe about 60 or 70% power. And this 60 to 70% of power, the design that I've done, you still able to take out the battery cell and make into a second product. What is the second product? It's already kind of recycle the battery cell and make into a second product. The second product you can make into like a power bank. You can make into it's still a battery that you can able to power your electrical appliances, like charging your drone battery. You can charge. You can actually power your fridge and use it to charge your laptop. So this is where I look into after 5 to 8 years, if the scooter doesn't able to use the battery anymore, can it still be able to recycle into a second product? So this is the recycle second life technologies that you have to keep in mind and put in place. So this is happening right now, and until today, the scooter that Eclimo is doing already been running on the road for almost like 6 years now. So just to show you that the scooter is powerful enough to be able to pull a cart, which is like half a ton, like 550 kilo. You can still pull a passenger. You can still pull a cart. It's strong enough that even though you pull a 550 kilo weight, it still can run for about 60 kilometer. I actually you provide the scooter for KFC to use it for food delivery, the chicken delivery. Police force are using it for their patrolling, and also we do have local council. Local council are using it to when you park your car illegally, they will come in and issue you summons. So for those people who use like food deliveries for the police, for the local council. For instance, that if they run 100 kilometer a day, they in the evening they would charge it just like before you sleep you charge your mobile phones. So at night they will charge the scooter. In the morning they will use it until at night or until evening. For instance, if they use 100 kilometer range, they are able to save about 7 kilo of CO2. That is a very tremendous savings for just a scooter usage, and that 7 kilo is if you talk about a year, you are actually saving about easily 2 to 2.5 ton of CO2. And that is only just one unit. Imagine if you have 10,000 or 100,000 scooters on the road, everyone will be able to enjoy a blue sky with less carbon emission in our environment. So I coming to my last one or two slides, whereby in year 2006, before I make into into electric scooter, I'm actually started doing smaller battery like power bank. In 2006, I've designed a power bank to charge mobile phone or to charge laptop, and uh, even all this design during that time, we can say that in 2006, when I designed a power bank, a lot of people still do not know what is power bank. I during that time I used to spend about almost like half an hour to convince or to explain why we need a power bank. So this is how hard when you design the product in the early stage. Just like 2008 when I want to design electric scooter, that's at that time it's very hard for you to be able um, uh, to design a scooter which you want to achieve 100 kilometer per hour. Of course, all this comes from during school days. I do collect some of the bicycle parts in a junkyard or in a so-called like a rubbish where people throw away all their parts. During that time, I still remember that I've collected all these bicycle parts and assemble into a bicycle which I use it to cycle to school. So that is the innovation parts that bring me until today, where I still believe that electric scooters or electric two-wheelers or motorbike is still a necessity transport for everybody to use it. So and all these years, I'm just fully focused and concentrate on developing rechargeable batteries, and hopefully one day I can able to I don't know how many people have heard about Hyperloop. Uh, Hyperloop is like a future transportation where it can bring you maybe from Penang to KL or to Johor within half an hour or within an hour. Hyperloop is a vehicle that you can actually running at 1,000 km/h speed. So that is also one of the vehicle that require batteries, where uh, batteries doesn't stop here. You have a lot of opportunity where it can able to power any devices that you can think of. So that's finished my um, journey of making electric scooter. And is there any question that anyone would like to know more? If not, I will have to. Okay. How can a car be charged by a wall plug? I believe you're asking about the using a wall plug to charge a car, right? Um, the wall plug is providing you 240 volts with 13 amp, and that is about 3 to 4 kilowatt of power. And a car, you need to have 50 kilowatt hour to 100 kilowatt hour. So it's possible to use a wall plug to charge the car, but it will take time. For instance, a wall plug to charge a bike, it will take about say 2 hours to 3 hours. But a car, it may take about 10 hours to charge. That is why uh, the answer is yes, you can use a wall plug to charge a car, electric car or electric bike, but it takes lower time to charge. And if you need a faster charging, you need to build a bigger power, for instance, a higher power from three-phase power, and you can charge the car within half an hour or 1 hour. So the answer is yes, you can actually able to charge from the wall, but it's taking a slower time to charge. Thank you. How come electric motor is so efficient versus combustion vehicle? Can combustion also be designed to become so efficient? They have a limitation for combustion. Combustion engine is already very good. As of today, combustion engine is at the so-called saturated. If the efficiency, no matter how you put in your research or development, the improvement will probably is only 1 or 2%, because there are so many components inside the engine that you will make the power loss. For instance, just now when I mentioned about 1 liter of petrol that goes in, you go through the burning, you go through the whole cycle, and you have a 30% of energy that you can use. Along the line, there are so many conversion that will make the whole power loss. That is where there is already until the maximum that you can't able to make it into 60% or 70%, because there are so many conversion required to be able for you to improve it to better percentage. But when you come to electric motor, it's so different, where the pulses go in and the power come out, because there's not much of mechanical movement. It's only cables, copper, induction wire. So that is where there is not much of movement. There's not much of mechanical, where you get uh, uh, power that goes in. You get about 90% of powers coming out. So so that is the difference of combustion engine and electric motor. So electric motor efficiency is always the best compared to a combustion engine. You mentioned prices that are comparable with combustion vehicle within 5 to 8 years. What can individual do to speed this up? It always boils down to how much we spend on developing a component. For instance, there is a controller, we call it like a controller to control the motor, control the battery. That controller, if you take it as like a computer 20, 30 years ago is very big and it's very costly. And there's so much research and development have put into the computer they spend a lot of development R&D and investment to improve from the big size computer until a very small computer, and the cost reduced. So these are the journey of people putting the investment, time, and development to improve until it reached to a point where everybody afford to own one. So it's the same as electric vehicle. Today, there are many people or companies are putting investment to improve the controller. So if the controller improve, is to reduce the cost and improve the efficiency of the controller. So it's the same as a battery. If you can improve a battery efficiency by making it smaller and make it lesser cost, this will definitely speed up the total cost of the vehicle. So the key is you need to spend your time on research, development, and to have more investment or funding into this area. Then only you are able to speed up to reduce the cost of the whole the whole electric vehicle. Thank you.
Okay, so thank you so much, Dennis. That is such a informative presentation. I learned so much about batteries and about engines that I never knew before. And thank you everyone for joining and for all of your questions. I hope that everyone has learned something today. Dennis, is there anything else you would like to add in the presentation?
Yes, I hope that I hope that everyone's looking into not only as electric vehicle, but the climate issues is it's a crisis, and whatever that we do, we must have a mindful that that we want to be able to reduce the carbon emissions and to take care of our climate. Today, probably we can see a blue sky when we walk out from our house, but it doesn't mean that if you are not, I mean, a few years down the road, probably it won't be the same as today if you don't manage the climate carefully. So thank you.
Yeah. One more thing I want to check with you, Dennis. I know that you do the research, you build the motorbike, and then is your factory also in Penang itself?
Yes, the factory is in Penang. Yeah.
Okay, that's exciting. So, the whole electric motorbike is produced and entirely in Malaysia. The first electric motorbike from Malaysia, correct?
Yes, correct.
Yeah. So thank you so much again for taking time to share with us. I hope that everyone has learned something or are inspired to do something in the transportation space to help reduce carbon emissions. Don't forget, our next session, we are also going to talk about climate change. But in this case, we want to talk about how to make nature a little bit greener. we want to talk about how, remember, if you were part of the session with Prof. Azizan, he talked about sinks, which is for carbon to sink into the ocean and the earth. And we're going to have someone talk about that from Tropical Research Center. So I'm really excited for that. I will share the links over there with everyone. And with that, I just want to thank you once again, Dr. Dennis, for being with us today. And thank you, everyone, for being here. I will see you guys next week.
Okay, thank you so much. Bye bye.
Thank you.